Well, it's your favorite physics teacher, John Frensley here, and today we're going to do some AP calculus. But first, let me tell you about my little endeavor here, World's Finest Physics. There's the website right there, and there you can find tutoring services for students of physics or any level of math, and also professional development for physics teachers and for math teachers at the secondary level. All right, so now that we've got that little advertisement out of the way, let's see here. Now, I have not seen these before. I am totally doing this cold. I've got my calculator handy. I may use it sometimes on a non-calculator part. Sue me. You know, it's I can do whatever I want. Okay. Temperature of a coffee in a cup modeled by a decreasing differentiable function. So apparently the AP calculus exam is installing the hot coffee mod. Okay, for t to 0 to 12, given an equation. What's with this? How am I supposed to write a solution here? It's like there's no space. Luckily, I have some extra paper here. Okay, approximate the derivative of c at 5 using this little interval right here. This is the yes calculator part. So c prime at 5 is approximately y2 minus y1 over x2 minus x1. And so that's whatever 69 minus 85. I don't know any basic like arithmetic or whatever. So it's negative 4 degrees Celsius per second. Does it say to include the units? Yes. Okay, show the work leads your answer and include units of measure. Use a left Riemann sum with 3 subintervals. Sure. Indicate by the data to approximate this value right here. So what I'm going to do for part B is I'm going to say, okay, so the width is 3 and the height on the left is 100. The width is 4 and the height over here is 85, the left-hand width, and then the width here is 5 and the height is 69. So it's just width times height of 3 rectangles, right? Okay, so we got 300 and I don't know what it is, 4 times 85, 340, and then 5 times 69, 345. So then this is 985. Okay, now it says, interpret the meaning of this, which is 1/12 as much. Why do I not believe that in the slightest bit? Did I do this wrong? I don't believe that. That can't be right. Oh, because that's just the last number. Never mind. Sorry. Okay, I told you this is unrehearsed and I am not starting the video over. Okay, 82. That's more believable. What was the problem with what I had before? This is supposed to be the average. This is supposed to be the average temperature. So 1 over 12 integral 12 C T dt is the average temperature of a coffee during 0 to t to 12 minutes. Okay, whatever. I'm a physicist. I use seconds all the time. Okay, right? Okay. So when I saw the number I had before, I was like, that can't be the average of this. And I was like, yeah, that can totally be the average of this. Okay, so make sure your answers make sense. All right. For 12 to 20, the rate of change is now this stuff. Degrees Celsius per minute. Oh, shoot. That means that this is degrees Celsius per minute, not degrees Celsius per second. Thanks, AP Calculus, for telling me the answer later on. Okay. Find the temperature of the coffee at time 20. Show the set of your calculations. Okay, so let's think about the fundamental theorem of calculus, whichever one the frick this is, okay? I know there's a first and a second one, and I could not give less of a damn about which one is which. So I'm going to say C at 20 minus C at 12 is equal to the integral from time equals 12 to time equals 20 of C prime dt, right? So what I'm going to do is I'm going to take the integral of negative 24.55. Really? Seriously? Is this pen running out on me right now? Wow, the pen ran out on me in the middle of my video. Geez, did you all see that? I want to make sure that you saw that in the... Yeah, it's gone, right? Okay, well, you've served me well, little blue pen. Go to heaven. All right, let's try another blue pen here. Okay, so integral t equals 12 to 20, negative 24.55 e to the 0.01 t over t dt. That's going to equal C at 12, which is 55, minus then the C at 20, which is what I want to know, right? Does that make sense? Okay, let's put this garbage in calculators. Okay, so 25. Okay, e to the point 0.1 t x, whatever you want to call it, divided by x. I got to make sure that I'm in radian mode for this. Okay, so let's see the function numerical integration 12 to 20 y1 dx. All right, so this is, I think it's 3 decimal places, right? Negative 14.671 C at 20 minus 55. So we're going to add 55 to that, and C at 20 is 40.329 degrees Celsius. That makes sense because it should be going down, 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 right? So it should be lower than any of the other ones, right? Okay. Let's see. For the model defined in part C, it can be shown that the second derivative is that. Yuck! For that, determine whether the temperature of the coffee is changing at a decreasing rate or at an increasing rate. The temperature is changing at a decreasing rate or an increasing rate. Okay, let me think about this really quickly. So, if the temperature is changing at a decreasing rate, what do decreasing rates look like? They look like this. The rate, which is the slope, is getting less, less, less positive or more, more, more negative. And an increasing rate looks like any part of this. It doesn't have to be the whole thing. It can be any part of this. Getting less negative or more positive, that's an increasing rate. So that looks at the concavity. So I'm going to say the decreasing rate is going to be if the second derivative is negative, and the increasing rate is if the second derivative is positive. So I'm going to say this. I'm going to say that this is a positive. This has to be positive. This has to be positive because it's from 12 to 20 over t squared, which again is positive because all the t's are positive. So since c double prime is positive for all t from 12 to 20, the is an increasing rate because it's a concave up or something like that, right? Okay, so that's the story there. Okay, a particle moves along the x-axis, so it has a velocity given by that. Okay, there is one time in this interval when the particle's not moving. Find this moment in time. Okay, well then that's just when this is equal to 0. Oh, sorry, this is when this is equal to 0. So it's going to be when 0 is equal to natural log t squared minus 4t plus 5 minus 0.2t, and it's 0 to 2. So let's go to my handy-dandy calculator here. Natural log of x squared minus 4x plus 5 minus 0.2x. Okay, and I'm going to set the window to 0 to 2. And I'm going to make sure my calculator is in radians. Okay, I didn't mean the table. All right, so now I'm going to calculate a 0. So I'm going to calculate a 0. Okay, so let's see, a left bound, bah, and a right bound, nah, and a guess, nah. Okay, so then this is at, so solution is t equals 1.426 seconds, right? Is this seconds? Oh, it's not even given any units. Okay, screw you, you math people. Can't even stand to put units on things. No, you'll never be scientists. Okay, less than TR. So this is TR. So less than TR. So if 0 is less than T is less than TR, the velocity is positive. So it's moving to the right. And how do I know the velocity is positive? Because there's a velocity right there. It's a positive number. Okay, find the acceleration of the particle. Okay, so for part B, the acceleration is d velocity d time. And we're going to evaluate the at time equals 1.5 to get the acceleration at 1.5. Okay, so is the speed increasing or decreasing? Okay, so now I am going to do math, numerical derivative with respect to x of y1 at 1.5. Wow, it's almost exactly -1. So this is -1. And so what am I going to say? Is the speed of the particle increasing or decreasing? Okay, so I'm going to say this. I'm going to say since v is positive and dv dt is negative, in other words, they both have opposite signs, the absolute value of v is decreasing since v and dv dt have opposite signs. Also, you can just look at the graph and see that the speed, which is the absolute value, decreases, then the speed begins to increase after TR. Okay, let's see. The position of the particle is x of t, and its position at time 1 is -3. Find the position of the particle at time 4. Okay, so I know that delta position is integral velocity d time. So the position at time equals 3, 4, at time equals 4 minus the position at time equals 1 is going to be the integral from time equals 1 to time equals 4 velocity, natural log of t squared minus 4t plus 5 minus 0.2t dt. Okay, so they told me this is -3. This is what I want to know. Let's evaluate this. Function numerical integration. All right, so from what is it, time 1 to time 4, y1 dx. Number is going to be 0.197. I did round that correctly, right? 0.197. So I'm going to add 3 to that, and I'm going to get 3.197. So x at 4 is 3.197. Why do I not believe that? I don't believe that because I got the sign wrong. This is minus -3. Minus -3. Okay, minus -3. So now I had to actually subtract -3. I'm sorry. Let's subtract -3. All right. -2.803. How did you know that was bad, Frensley? How did you know there was something wrong with that? Because the particle only moves like 0.2 of a meter. Let it be meters. Okay, fuckers, can you just do units, okay? So you can't go from -3 to +3 in 0.2 of a meter. That's how I knew something was wrong, right? Make sure your numbers make sense, you know? Right. Find the total distance traveled by the particle from 1 to 4. Show the setup for my calculations. Okay, now get this and get it good. The velocity versus time kind of looks like meh. And what was this time right here? This moment in time was 1.426. So this is 1.426 seconds. So what you're going to get is you're going to get from 1 to 1.426, you're going to get a positive area. That's going to be a positive distance. But then from there to 4, you're going to get a negative area. So I'm going to say that distance, capital D, lowercase d is for differential operators, is going to be the green integral, 1 to 1.426 natural log t squared minus 4t plus 5 minus 0.2t dt, right? And then this is the orange integral from 1.42 to 4 natural log t squared minus 4t plus 5. Can you see all that? Okay. Minus 0.2t dt. But because this is negative, I have to subtract the negative in order to add. Say I want to add 2 positive numbers for distance. Total distance is always positive. Okay. So what I'm going to do is I'm going to functionally numerically integrate my crappy function from 1.1 to 1.426, okay? And so for the green integral, I get 0.10296. I'll round it more appropriately later. And then if you look here, 1.426 to 4, all right, that is going to take a little while. What? Why is that not? That should be a negative number. Why is that not a negative number? Okay, did I? Oh, dang. You know what I should probably do? I take it back. What I should probably do is look between There in 4, 1 and 4. Aha! There's another time it crossed the axis. Well, okay, so I got to trace, find a 0. Okay, find a freaking 0. Find another freaking 0. Okay, 2.883. 2.883. Okay, that's the negative area. Now I have to do the blue integral. 2.883 to 4 natural log all this shit dt. Okay, so 2.883. Okay, all right, so I'm getting a negative. So now this is negative. So we're going to subtract the negative, make it plus 0.38051. Gosh. Okay, and then I have to add to this. Oh, this is awful. 2.883 to 4. This is taking me way too much time. Okay. 0.47466. So I'm going to take u minus u plus that. And I'm going to get a total distance of 0.958. I would call it meters. Okay, that was AB Calculus's yes calculator section. BC had the same hot coffee mod, but they had a different here. Let's see what's going on here. We have also particle motion like the other one, but this is in an XY plane at time t seconds, x and y. We know the derivatives, which are the velocities. So in my world, this would be called Vx, and this would be V subscript y. Okay. At time, we have the point, so that is x at 2, y at 2. Find the speed of the particle at t equals 2 seconds. So here's what you need to know about speed. So speed is the Pythagorean theorem of the x and y components. So what I'm going to do is Vx at 2 is going to be 8 times 2 minus 2 squared, which is 12. I hope I'm doing that right. I am not about to get this. Okay, so actually, I don't know. Maybe I should do this. Maybe I should go to parametric mode or something like that, and then be all like 8t minus t squared, and then also negative t plus the square root of t raised to 1.2 plus 20. Who actually does this? Okay, and then I'm just going to do, okay, so there's 12 and 2.722. So the Vy at 2 will be 2.722. So let's do the square root of 12 squared plus 2.722 squared. Okay, because 12 is notably bigger than that, the answer is going to be really close to 12. That's how the Pythagorean theorem works. If one of the numbers is much bigger than the other one, then the answer is close to the bigger one. So 12.3. So this is going to be 12.305. And I would call this meters. Is it meters? Does it mean centimeters? Centimeters per second. Okay. Okay. So set up. Find the total distance traveled by the particle over this time integral. So you have to integrate the speed d time. Okay. So for this part, we're going to integrate speed d time. So that's the integral. Where are we going for 0 to 2, 0 to 2, 0 to 2? The square root of, 8t minus t squared plus negative t plus the square root. Did I do this correctly? I hope I did. Negative t plus the square root of t to the 1.2 plus 20 squared dt. Okay, now is there a way I can do this? Can I do it in the calculator? Let's have a look. I'm going to do not the numerical derivative, function numerical integration. I'm going from what again? 0 to 2. Okay, and then I'm going to do this. Vars, y vars, parametric x1 squared plus vars, y vars, parametric y1 squared. Oh, I got to take the square root of this. Oh, this is going to be bad. All right, let's try that again. Vars, y vars. I didn't mean that. Vars, parametric, y vars, parametric, that squared. Plus, why am I outside the radical? All right, vars, y vars, parametric, y1 squared, dt. Okay. 15.91. Okay, so 15.901, sorry, 902 centimeters. Okay. Find the y coordinate of the position of the particle at the time t equals 0. Show the setup for your calculation. Okay, so how am I going to find the y coordinate? So what I'm going to do for part C is I'm going to do this. I'm going to say I know that y at time equals 2 is 6. It says that right there, okay? Find the y coordinate. So I'm going to say y at 2 minus y at 0 is the integral from 0 to 2 vy d time. So this is 6. This is what I want to know. This is the integral from 0 to 2 of negative t plus the square root of t to the 1.2 plus 20. And I'm going to use my calculator for that. So now I'm going to take just the integral from 0 to 2 of just, let's see if I can do that. That looks cute. All right, so I'm getting 7.17. Okay, so 6 minus question mark is 7.174. So if I do 6 minus that answer, not an actual question mark, I get y at 0 being negative 1.174 centimeters. Okay. Finally, part D. For 2 to 8, the particle remains in the first quadrant. Find all times when the particle is moving toward the x-axis. Okay, toward the x-axis. What does that mean? That means moving down if it's in the first quadrant, right? It means moving down in some way. So that means Vy is negative. So what is Vy? Is negative t plus the square root of t 1.2 plus 20 has to be less than 0. Well, this is 2 to 8. So why don't I just graph it? Okay, so now I'm going to go back to function mode. Okay, let's delete my parametric equations just so I don't, leave them sitting in my calculator. Okay, it's like, leaving it is like leaving a surprise for your wife in the toilet. You want to flush. All right, so here we go. Plus 20. That was not what I wanted you to do. I wanted you to do an exponent, please. Oh, heavens. All right. Insert an exponent of 1.2. Okay. Now, I want to know when this is. So I'm going to do a window from 0 to 8. And let's see what I get for a graph here. Okay. All right. Well, find all times t in that interval. Okay, so let's do trace, calca 0, boop, boop, boop. Okay, so if we're moving down, we start here. So it's going to be 5.222. At that moment, you're not moving toward or away from the x-axis because your y velocity is 0. And then including 8. Because this includes 8. All right, so that is the times when you have a negative velocity and you're moving down. Okay, so that was 3. Now I have 6 no calculator problems to do. I have my calculator standing by just in case. Okay, the depth of seawater at a location can be modeled with function h set as a differential equation under feet, hours, time equals 0 is known as that. Okay, portion of slope field. Sketch the solution curve. Wow. Thank you so much for helping me out with that. Geez. Wait. Okay. 0 to 5, it can be shown that the height is greater than 1. Yeah, it can be. Find the value of t for which h has a critical point. Okay. Oh, that's just when the derivative equals 0. All right, well, and that's just where the derivative equals 0. So the dh dt is equal to 0. All right. Well, the critical point corresponds to relative minimum, maximum, or neither. I mean, can you use your fucking eyes? That's a relative maximum. Okay, how clueless are you? Okay. All right, well, I'm just going to do this. dh dt is 1/2 h minus 1 cosine of t over 2, and dh dt is 0, okay, equals 1 half h minus 1 cosine. Now this is why they said this. H of t is greater than 1. So you know this is not the thing that is 0, right? This is. So then when is cosine equal to 0? I don't actually know. Is it when the argument is equal to pi over 2? So t equals pi. Yeah, that checks out, doesn't it? Okay, so t equals pi hours, right? Okay, so determine whether the critical point, find the value of t. Okay, I did that. Times one. The critical point corresponds to relative minimum, maximum, or neither. Okay, well, what do you want me to say, AP Calculus? Can I just look at it and say, use your effing eyes? Or do I have to say this? Do I have to say, okay, well, dH dt equals 1 half h minus 1 cosine of t over 2. Okay, now watch this. H minus 1 is positive both before time equals pi and after time equals pi, but the cosine of t over 2 was positive, now negative, making dh dt be positive than negative. If you go from a positive to a negative slope, that is a relative maximum. I mean, do you need me to write that? I don't know, okay? All right, here we go. I justified my answer, I feel like, pretty well. I didn't write anything, I just said it, okay? Open up your freaking ears. Use separation of variables to actually find this. Okay, well, no, I don't want to do that, okay? But I guess I will because I'm making this video anyway. Okay, so I'm going to switch colors. I'm trying to switch colors periodically. Let's do this in red because I'm mad. Okay, so dH dt equals 1 half h minus 1 cosine of t over 2. So he's going to come down. dH over h minus 1. Bring him up. 1 half cosine t over 2 dt. Now we're going to drop an integral onto both sides. And I personally integrate with a plus c is what I'm going to do. So this is natural log h minus 1. This will integrate up into sine, and the derivative would pull out a 1 half, so the integral will pull out a 2, which kills that. Okay, that's fine with me. Plus c. Now, I'm going to e up the other side. So h minus 1 is going to equal a new constant that's not the same as that, but Jesus doesn't know what either constant is, so who cares? Okay, sine of t. Okay, now, what were we told? H at 0 equals 4. I'm going to change colors for finding the constant, okay? So here we go. So 4 minus 1 is equal to C2 e to the sine of 0, which is 0. That's 1. So C2 is equal to 3. So your particular solution is H minus 1 equals 3 e to the sine t. So then that'd be H equals 1 plus 3 e to the sine t. All right, is that the end of that problem? Thank freaking goodness. Okay, the graph of the differentiable functions are that. A horizontal tangent at x equals -2. Okay, so the derivative is 0 there. And linear beyond in the positive half plane. Let R be a region of the second quadrant bounded by the graph of f. Vertical line and the x and y axes all good. Regionalized area of 12. The function g is defined as this. Find the values of g at -6, g at 4, and g at 6. Okay, these are problems I have to actually think about. I'm just going to tell you right now. I don't mind telling you. Okay, so I'm going to say this. If g of x is integral from 0 to x, f of t dt, then g at -6 is the integral from 0 to -6 f of t dt, which is the opposite of the integral from -6 to 0 f of t dt, which we were told this is 12. So that answer is -12. Okay, g at 4 is the integral from 0 to 4 f of t dt. Okay, and then that's just this triangle, which is 4, okay? And then g at 6 is going to be integral from 0 to 6 f at t dt. Okay, are we following along here? Okay, we have to take the integral of this triangle, which is 4, and the integral of this triangle, which is 1, a negative 1, so then that makes 3. All right, so 4 plus negative 1 makes 3. All right, for the function g, defined in part A, find all values of x at which the graph of g has a critical point. Give a reason for your answer. Okay. On this interval. Oh, just between 0 and 6. Not the endpoints. Thank goodness for that. Okay, then the critical point is at x equals 4 because that is where the f, so I'm going to say this. Since g prime equals f and f at 4 equals 0, the critical point is x equals 4. Is that what it was asking for? Give a reason for your answer. Oh, well, that's it. All right, the critical point is the derivative equals 0, which what happens there. They're not asking me whether it's a max or min or anything like that. By the way, it would be a local maximum because you go from a positive derivative to a negative derivative. So the graph of g would be going up and then down. Okay, the function h is defined by this. Okay, find the values of h at 6. H prime at 6, and H double prime at 6. All right, this is really hard for me. I'm just going to tell you that right now. I have to think about it every time because you can't just say, okay, so I'm going to say this. I'm going to say H of x is equal to f at x minus f at negative 6. So I'm basically doing the derivative of the integral of the derivative is himself, but I have to do the other fundamental theorem of calculus where I have to plug in the upper bound minus the lower bound. What is this? What is f at negative 6? That is 0.5. So this is 0.5. Right. What is h at 6? H at 6 would be f at 6 minus 0.5. F at 6 is negative 1. So it'd be negative 1 minus 0.5, which is negative 1.5. Great. Now, the derivative of h is also the derivative of f. H prime is f prime. Why is that? Well, because if you derivative and derivative, this is a constant and it's effing gone. So h prime is f prime, which is the derivative. At 6, that slope is negative 1/2. So that's negative 1/2 because that's the slope right there. And h double prime is the derivative of a constant, which is 0. Lines have 0 for a second derivative. Okay. Oh my gosh, I want to be done with this. This is 9 questions. It's all calculus. Okay, consider the curve defined by that shit. It can be shown that whatever. There's a point on the curve near 2, 4, near. With x coordinate 3. Wait a minute. The point on the curve might be at least 1 away. There's a point near x equals 2 with x coordinate 3. Who would? Yeah, it's like 1 away, maybe, or more if it's at an angle. Use the line tangent to the curve at 2, 4 to approximate the y coordinate of this point. Okay, so in other words, what you have. Okay, let's look at the. Okay, so first of all, here's what I'm going to do. I'm going to take dy dx, which is negative 2x over 3 plus 4y. And I'm going to say, what is dy dx at the point 2, 4? So that's going to be negative 2 times 2, because that's the x coordinate, over 3 plus 4y, which is 4. And I'm not allowed a calculator. And this has 19 in the denominator. Why? Screw you and your prime numbers. Okay. So, okay. So this is a negative. So here's what I'm seeing in my brain. What I'm seeing is that this curve is like some snaky shit. And then this 2, 4. This is the point on the curve. All right. Does this solve this? Okay. Okay. I'm going to stop for resist the. No, I'm going to use my calculator. Okay. Shut up. Now, you out there in internet land, just shut up. I'm just checking. 2 squared plus 3 times 4 plus 2 times 4 squared is 48. Okay, so this point is on the curve. All right. There's a point on the curve near 2 comma 4 with x coordinate 3, which does solve this. Okay. So here is the x coordinate of 3. And so what I'm supposed to do is build a tangent line and say, okay, well, here's my guess of where the x coordinate of 3 is. Okay. So how am I going to build a tangent line? I'm going to be all like y minus y1 equals slope 19 x minus x1. And then I'm going to say, okay, here's the approximate y coordinate. Here's the x coordinate you asked me about. That's 1. 4. All right, 4 minus 4, 19. I'm not simplifying that. Screw you and the horse you rode in on. Okay. Is the horizontal line y equals 1 tangent to the curve? Okay, how am I figuring that out? Is the horizontal line y equals 1 tangent to the curve? Okay, so here's what I'm going to say. Y equals 1 has a derivative of 0. All right, let's start with that. Derivative of 0. So I'm going to say dy dx equals negative 2x over 3 plus 4y, and I'm going to make that 0 because y equals 1 has 0 slope. Okay, so now let's solve. Oh, well, that was easy. X equals 0. Okay, so the only place the derivative is 0 is at x equals 0. All right, so then let's go to x. Oh, hey. So if x equals 0, then what is the coordinate? So if x equals 0, that's the coordinate. So whatever this snaky thing looks like, at x equals 0, it has 0 derivative. But the question is this y equals 1 or not? So now I'm going to plug in x equals 0 to here. 0 squared plus 3y. Oh, let's just do 3 times 1 plus 2 times 1 squared equals 4. There's no way. There's no way. That's not it at all. So no, since the derivative equals 0 at x equals 0 and y at x equals 0, y equals 1 at x equals 0, or I'll say 0 comma 1 is not on the curve, right? Okay. Okay. Shut up. I am going to just go to Desmos and I'm going to ask Desmos. Okay. I'm just going to make sure. X squared plus 3. He had Desmos open already. Yeah, because usually I have to do this. Okay. I'm just going to check and make sure. Okay. See, y equals 1 is not here. Let me help you out here. Y equals 1 is not a tangent line because this point right here is not 0 comma 1. Okay. So that's the story there. And I'm sticking to it. The curve intersects the positive x-axis at the point great. Is the line tangent to the curve at this point vertical? Okay, let's find out. The curve intersects the positive x-axis at the point radical 48 comma 0. All right, so let's do dy dx equals negative 2x over 3 plus 4y. So that's going to be negative 2 times radical 48. I don't... this is y equals over 3 plus 4 times 0, which is not 0, or not 0 or undefined, really. So I should say that. But it's not undefined. So since dy dx is defined, the slope of the tangent is diagonal, since it's not 0 either. Okay, let's just double check. Yeah, that looks pretty diagonal to me right there. All right. Oh, no, it's particle motion. For time greater than 0, a particle moving along another curve is defined by bull. At the instant the particle is at this point, the y-coordinate of the particle's position is decreased. It's a related rates problem. 2 units per second. At that instant, what is the rate of change of the x-coordinate? Okay. Y cubed plus 2xy equals 24 Okay, the derivative of y cubed is 3y squared dy dt. And this is a product rule. 2x times the derivative of y is dy dt. Then the derivative of 2x is 2 dx dt times y, and then that's 0. Okay, so now, 4 comma 2. Okay, so then 3, 2 squared, dy dt is decreasing at a rate of 2 units per second, so negative 2, plus 2, the x is 4, dy dt is negative 2, and then 2 dx dt is what I want to know, and then y is 2. Okay, what the frick is this? Is that negative 24? I can't math. Is that negative 16 plus 4 dx dt's? Bring it over. 40. 4 dx dt's equals 40. So dx dt is 10 units of length per second. Let's say units per second. Yeah. All right, there's your related rates. And finally, for the AP Calculus AB, and I'm going to have to go back into the BC. I'm like barely halfway through this. Okay. Functions f and g are defined like so. R is this region, right? But do not evaluate an integral that gives the area of region R. So that'd be the integral from 0 to 2 of f of x is on top, and then g of x is on the bottom, dx. That's the area. I'm not evaluating it. Let S be the region bounded by the graph of the g and the x-axis from 2 to 5. Region S is the base of a solid. The solid at each x, the cross-section perpendicular to the x-axis is a rectangle with a height equal to half its base in region S. Okay, so in other words, I'm going to say that the area of each of the rectangles is 1/2 S times S, where S is actually lowercase s, like this is S and this is half of S, right? Does that make sense? That is going to be like these lengths here that you see, which is basically the same as g of x. So the area is 1/2 g squared. And so find the volume of the solid. So the volume is going to be the integral of a dx. So it's going to be the integral from 2 to 5. So the integral from 2 to 5 of g squared. What was g? That's going to be, but the area is 1/2. X squared minus 2x all squared dx. Okay. Find the volume of the solid. Show work that leads to your answer. Okay, I freaking do this. 2 to 5, 1/2. Here we go. We're going to FOIL. Okay, that's x to the 4th. That's 4x third, I think. And then that's going to be plus 4x squared, I think, dx. Let's bring the 1/2 in just because I want to have smaller numbers. Okay, integral from, all right, raise up the power, divide by the new power, raise up the power, divide by the new power. I hope I'm doing this right. Raise up the power, divide by the new power from 2 to 5. I badly don't want to do this. I don't want to do 5. I'm not simplifying this. Screw you and everybody. All right, 5 to the 5th power minus 1/2, 5 to the 4th power plus 2/3, 5 to the 3rd power minus, I can use parentheses, 1/12, 2 to the 5th minus 1/2, 2 to the 4th. I know it's 32 and 16. You can keep your mouth shut if you'd like, okay? Cubed. That's what the volume is. My gosh. Okay, right, but do not evaluate. Oh, my favorite words. An integral expression that gives the volume of the solid generated when S is rotated about y equals 20. So if y equals 20 is up here, then I need to rotate the big radius and the small radius. So I'm going to call this little r and I'm going to call this big R. Big R is 20. Little r is going to be 20 minus g. Yeah. Okay. So that's what it's going to be. All right. So integral from 2 to 5 of pi big R squared minus little r squared dx. So pi integral from 2 to 5. The big R squared. What is this? Oh, x squared minus 2x. No. Sorry. 20 squared minus x squared minus 2x squared dx. All right, I think I did that right. All right. You can tell I'm running out of brain juice. And I have 3 more to do, and they're the hard ones. Okay. Screw you, we did you already. Hey, what's this? Screw you, we did you already. Oh, what? Okay, now I don't get a calculator for this. The function f, I know exactly what f stands for, is twice differentiable for all x with the, you start at 0, thanks. Values of the derivative are up there. For greater than 0, the function h is defined by this. Wow. Find the value of h prime at pi. Okay, so what I'm going to do, again, I have to do this every time. I'm going to just make up a new function. I'm just going to call it, let's say just g, because that's a letter that's not being used yet. So let's let g of x be the square root of 1 plus f prime at t squared. And then that means that h is the integral from 0 to x of g of t dt. Sorry, I meant for that, right? Okay. So I have to do this every time. I can never remember the fundamental theorems of calculus. Shut up, okay? Stop making fun of me. Okay, so that means that this is big G, the antiderivative of g, or one of them, minus big G at 0. So then, if I take the derivative, then this goes back to g, and then this is a constant that's going to go away. Now, what did I say g was? It was this. So I've just proven to myself, because I can never remember this, that the square root of 1 plus f prime of x squared is that. Okay, so now I'm being asked what is h prime at pi? H prime at pi would be the square root of 1 plus f prime at pi squared. The square root of 1 plus f prime at pi is 6 squared. The square root of 37, I think. I hope I'm right about that. All right, what information does this provide about the graph f? Okay, I know this. This is the, so part B, this is the length of the function f's path from x equals 0 to x equals pi. So that is a arc length type calculation. Okay. Use Euler's method. No, what if I don't want to? Okay, you can't make me. Starting at x equals 0, 2 steps. Approximate f at 2 pi. Oh, that's not so bad. Okay, so here's what I'm going to say. Okay, again, I have to write this out every time. I can never remember Euler's method, okay? Euler's method, that's ancient. Like, math goes out of style. It's not fashion, okay? Euler's method, that's ancient. It works, especially if I have a computer, which I don't. All right, so what I'm going to say is I'm going to say that the derivative is approximately delta y over delta x, which means that delta y is the derivative times delta x. So for my first step, the derivative is 5, the delta x is pi, and the delta y is y at pi minus y at 0. And we were told that y at 0 is 0. So y at pi is 5 pi. Step 2. Delta y equals f prime delta x. The delta x is again pi, but the f this time is 6. And the delta y is going to be y at 2 pi minus y at pi. No, that's a times. All right, so then y at 2 pi minus 5 pi is equal to 6 pi. So y at 2 pi, my approximation is 11 pi. Find this. Wait, you just find this integral. The integral has nothing shit to do to anything else. Just find this integral. Okay, it's gonna be integration by parts. Okay, so let's see. T plus 5, 1, 0, 0, 0, 0. Okay, and then cosine of t over 4 integrates to sine, negative cosine, negative sine. Okay, if I take the derivative, it brings out a 1/4. So taking the antiderivative brings out a 4. And then it's going to bring out another 4. Okay, so let's do this. Plus t plus 5 times 4 sine t over 4 minus, the signs alternate. Oh, it's minus a negative. Shit. 16 cosine t over 4, 0, 0, 0, 0. That's the end of it. Plus c, because it's an indefinite integral. I'm not looking up whether that's right. I don't have a way to take an integral. Actually, I think Symbol Lab has an indefinite integral calculator. Let's see what they have to say. Symbol Lab indefinite integral calculator. Will you do it? Indefinite integral calculator. What was that integral again? Okay, so let's just go. Come on. Okay, x plus 5 times cosine of x over 4. Go. Don't tell me it's going to take you that long. It's just integration by parts. 4x sine. Do I have that? All right, 4x sine. Yeah, that's one of my terms that they just distributed. 16 cosine, I have that. And the 20 sine, I have that too. Okay, good. All right, I did it right. I hate integration by parts. Last segment. Okay, number 6 is always one of these. Okay, let's see if I can get to the end without saying any more curse words. Okay, Maclaurin series. It can be shown that the Maclaurin series has a radius of convergence to 6. Yeah, I can just see that visually. All right, determine whether the Maclaurin series for S converges at x equals 6. So in other words, does sum n equals 1 to infinity and it's 1 over n squared 6 to the n over 6 to the n. Shut up. Okay, does this converge? No, it doesn't. Okay. How do you know, Friendly? Because this is basically 1 over n, which is the harmonic series which diverges. In fact, let me go ahead and just say n equals 1 to infinity. This is now 1 over n plus the same, or let me just, the same sum, n equals 1 to infinity of 1 over n squared. This converges, but this diverges. This is a p series where p equals 2. Greater than 1, it converges. This is where p equals 1, so it diverges. And infinity plus finite is infinity, so it's going to diverge, okay? It can be shown that the, that f at negative 3 simplifies to this, and that the first 3 terms sum to that. Thank you for not making me do that. Show that the difference between the true value of the function and the sum out to 3 is less than 150. So here's how we're going to do that. What we're going to do is we're just going to take term number 4. So term number 4 is the first 3 terms. So that's n equals 1, 2, 3. So this would be 4 plus 1 over 4 squared times 1/2. Remember, we really just look at the absolute values. Okay, 1/2 raised to the 4th power. So this is going to be 3 over 16 times 1 over 16. And so that's going to be 3 over 256, right? And so this, which is less than 150. So then I'm going to make a verbal argument. I'm running out of time. I just want to finish this video. So I'm going to make a verbal argument that this difference has to be 3 over 256 or less, and that's less than 1 out of 50, okay? And that's just by taking the next term. Find the general term of the Maclaurin series for f prime. Okay, so if f is sum n equals 1 to infinity, n plus 1, or n squared 6 to the n, x to the n, then for the derivative, it's sum n equals 1 to infinity, n plus 1 over n squared, 6 to the n. And then this, we just take the derivative of this. Multiply by the power, take one away from the power, and it's that simple, right? Okay, so that is f prime. Okay. Find the radius of convergence. I'll bet you it's the same thing. I'll bet you it's going to be 6. Let's have a look here, okay? So when I ever do a radius of convergence, I'm always going to do a ratio test, and it's going to go something like this. Okay, we're going to look at an plus 1 over an. It has to be less than 1. We're going to take the limit as n goes to infinity. Okay, now I'm going to color code these. This is going to be orange. So limit as n, are you seeing this? Yes, goes to infinity. Okay, an plus 1 is going to be n plus 2, n plus 1, x to the n over n plus 1 squared, 6 to the n plus 1. Now I'm going to make the bottom green. Okay, now it's going to be this, but the reciprocal of it. N squared. Oh, hey, that partially cancels. Partially cancels. Okay. All right, so this is going to partially cancel. Okay. N, 6 to the n over n plus 1, x to the n minus 1. And that has to be less than 1. Okay. Now, what am I wanting to prove here? I want to prove that all the n's limit to just 1. So in other words, I have n plus 2 on the top and n over n plus 1 and n plus 1. And then I have 6 to the n, 6 to the n plus 1. That just whittles down to 6. And then I just have x, because that's how that divides. Limit as n goes to infinity. That is all worth 1. So what I get is I get x over 6. That's the x and that's the 6. Is less than 1 or greater than negative 1, which means that x has to be between negative 6 and 6. So the radius of convergence is 6 again. Okay. Let G be this new thing. Use the ratio test to determine its radius of convergence. Okay. Am I out of paper? Okay, I got one more sheet here. Okay. So, ratio test. Okay, so I'm going to say limit as n goes to infinity. I'm going to color code it. An plus 1 over an. My stars, I don't want to do this. Okay. All right, now let's write this out. Limit as n goes to infinity. Okay, orange. Orange is going to be n plus 2, x to the 2n plus 2, n plus 2 squared, 3 to the n plus 1, n plus 1. I meant to say n plus 1 here. All right, did I do all that correctly? I hope I did. Okay, and then this will be n squared, 3 to the n, over n plus 1, x to the 2n, and all that needs to be less than 1. All right, now let's collect together the terms that I care about, which are going to be u, nope, u, I will care about eventually, u, this. Okay, now what is this turning? I'm going to simplify it in a second. I'm so confused. Okay, 1 plus 2, and then x to the 2n. Okay? Okay. Did I do this correctly? Yeah, okay, so this is now 1/3. This is 1/3. This is a third polynomial power over a third polynomial power. So that limit is going to go to 1. Limit as n goes to infinity. All right, what the frick is this? X squared over 3, less than 1. Okay, so you need x squared over 3. Oh, the limit is done with because I took the limit already. To be less than 1. So x squared has to be less than 3, which means that x is between radical 3 and negative radical 3. So the radius of convergence is radical 3. All right. If you sat through this whole video, I'm sorry for boring you.